Okay, question 7 is really testing your ability at drawing graphs. So, to me there'd be a lot of sketching going on with this. Y equals 3x first of all I draw, plus 3. So what's that graph looking like to me? Well, that graph is going at 3 there, and you expect it to go through like that. Now, the important point is obviously where it crosses the x-axis, because the modulus means that any negative values will become positive. So this value here is when it equals 0. If you take the 3 over and divide by 3, then that'll tell you that's minus 1. So y equals the modulus of 3x plus 3 is going to be, the graph will come up here first and then go through there. Obviously you use a straight line. There's minus 1. So there's the first part covered. Part 2 then asks us to sketch the curve x squared minus 1. Well, that's not too bad, because y equals x squared minus 1 is your y equals x squared but shifted down by 1. So there. This point here and this point here are the important points, and they're minus 1 and 1. If you put that equal to 0 and solve it again. So in effect your y equals the modulus of x squared minus 1 is going to be the same curve, but it will curve down here. As soon as it hits minus 1 it will then bump up and it will come this way. Again, plotting the important points here. So here it will be minus 1, here it will be 1, and this point here will now be 1. We then look at B, and it says we've got to solve the equation where these two graphs, this graph and this graph, are equal to each other. So what I would then do is do another sketch before you even attempt to try and work out what's going on here. So the other sketch I would do is both of them together. Now you'll notice that there's a common point there. Actually, I'm just going to redo that line. We'll do these with straight lines. So we've got first of all the y equals the modulus of 3x plus 3 there, and we've then got the y equals x squared minus 1 graph. Now if we just go back and look at the y equals x squared minus 1 graph, it comes in, then curves up, then comes out again. So if it's coming in at a curve, then if I sort of make that point there, then it'll also curve outwards and hit here again. So what we've got though is that isn't actually happening, is it? Sorry, that graph is incorrectly drawn. The curve in itself comes in and intersects there and hits this point. Then it bumps up through here, coming onto the side, and then the curve comes out here. But the curve will also come out to here, and there will be a point at the top where there's also an intersection. Now for me that's just my sketch to understand what's going on. You won't gain any points or lose any points for that. So we're now asked to solve this. So what I'm going to do here is I'm going to look at when they intersect. Well, they intersect at 4 individual points. Here, 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 and then at the top bit up here. Now these 2 points, I'm going to break them up. This here is when the graph is normal, when the x squared plus minus 1 is normal. These 2 points, why do they happen? Well, they happen because this has been used as a modulus. So we've actually got 2 equations to solve. We've got when 3x plus 3 is equal to normal x squared minus 1, and that will give you the 2 values here and here, so the 2 green dots if you like. And we've also got when 3x squared plus 3 is equal to 1 minus x squared, because it's the opposite of this. This graph here in effect is if it was flipped over in the x-axis, so you times it all by minus 1. So we solve this x squared, take your 3x over, and take your 3 over. That then becomes a quadratic, minus 4 and plus 1. And we solve the same thing here. Bring my x squared over to this side and bring my 1 over. Which will then give me x plus 1, x plus 2. So then I get my x values combined together to be minus 2, minus 1, and then we've got 4. But have I missed something out here? Have I made a slight mistake? Is there something that I've missed? It's actually from my sketch. My sketch, I presumed here that there's 2 points at this point and this point, but there isn't. And this is where you sort of, I'm sort of talking you through how you would think about it in the exam. This curve will actually then you've now worked out that it's going to curve underneath that line, so it won't go above it and back again. So there is no need then for that point. This is crucial though for what the next part's going to ask us, because then it says hence solve for when the straight line graph is less than the x squared minus 1 graph. Now it'll be less than, if I drew again just another sketch of this, so it's coming in here, bumping up, coming around this way. If I just show you the straight line there, it's going through here, and through here, and through here. When is it less than? Well, it's less than when the curve is above it. So the curve goes above it here, so it's this point here, and the curve goes above it as a greater value at this point here. So it's this value and this value. So it's when x is less than minus 2, and x is greater than this value here, which is 4.